As we work with inverse functions, one rule for inverse functions is that functions f and g, so let's say two functions, are inverses of each other provided the following is true. The f of g of x is equal to x, and the g of f of x is equal to x. Meaning if I were to compose two functions that were the inverse of each other, I would get x, the identity function, as my result. To show that, we're going to use the two functions we just worked with. So y equals 3x minus 1 was a function that we just practiced finding the inverse for. Our inverse was y equals x plus 1 over 3. So I've got those both listed here. Then I just changed the notation and called this one f of x and this one g of x for the purposes of composing the two of them. So as I find the f of g of x first of all, the f of g of x means plug function g into, so this function goes into x in function f. So I have 3 times in parentheses, because I'm replacing the x with a whole other function, x plus 1 over 3. And then I subtract 1 from that. Now if I simplify this expression, I notice it's 3 times a fraction. Well, 3 times something over 3, the 3's cancel, and then the parentheses would go away. So I'd have x plus 1 in parentheses, which have now dropped away, and then a minus 1 on the outside. Well, 1 minus 1 happens to be 0, which means that the final result of our composing of these two functions is x, just like we needed it to be. Now what if we go the other direction? Let's find the g of f of x. If I compose them in that order, so now I take function f and plug it in for x in function g. So x is replaced with a new function, which happens to be 3x minus 1. And then I add 1 to that, and I divide everything by 3. Simplifying this expression, because I'm adding in the numerator, I can drop the parentheses, and then negative 1 plus 1 happens to be 0. So that leaves me with just 3x in the numerator, which is divided by 3, which just so happens to equal, after I cancel the 3's, x. So the g of f of x is also equal to x, just like I needed it to be. So this proves that these two functions are indeed the inverse of each other. This property is something that will become very important to us in a future lesson. So it's something that we'll refer back to. You don't have to practice it a whole lot. It's just something that we wanted to show and be able to understand so that we can use it for other things in the future.